I'm going to show you how to create a matrix, then we'll plug them in our calculator, and we'll use those matrices to solve these systems. So in a matrix, the size of the matrix is dictated by how many rows there are, and then how many columns there are. So in this equation, notice the x's and y's and equals and answers are all lined up, and it has to be in this form in order for it to work. And we create a matrix which kind of has these big brackets, and then we eliminate everything but the numbers. So 2, 3, 18, 1, -5, -17. And the size of this matrix is 2 by 3. It has 2 rows and it has 3 columns. Okay? So turn your calculators on. Your matrix button is right here above the x to the -1, unless you have a TI-83, and then I think it's its own button somewhere else. So push second, matrix, and in here you see 3 columns. If you want to use a matrix, then you use the name column. Calculate is where you find all the formulas, and then edit is how you change a matrix. So I'm going to go over to edit, push enter, and it first asks me how big do you want it to be. Mine already says 2 by 3, whatever yours says, change it so it's 2 by 3. Anybody having trouble getting here? Now, as you enter the information, it does it row by row. So just plug in all that stuff. So it should look like this. Anybody having trouble filling that out? Everybody good? Okay. Now, we want to take, so this is matrix A. We want to take A and do what is called reduced row echelon form of A. Now, there is an entire mathematics class dedicated to matrices. It's called linear algebra. I've taken it twice. I loved it. It's a great class. I mean, you can do a lot of neat things. So we're just barely brushing the surface. But RREF stands for reduced row echelon form, which basically means you're simplifying this matrix using elimination. It's a little more complicated than that, but that's as much as you need to know. So before we can plug this in, we need to exit out. So everybody push second, quit. And we need to find the RREF button. So once you've exited out, go back into matrix. And then you go over to math. And there are lots of calculations you can do on matrices. RREF is near the bottom. So I like to go up from the bottom and find RREF. Now, the reason we exited out, if you're still in the edit column, and then you find the RREF, it will stick the RREF inside the matrix, which will cause the calculator to give you an error. So before you find the RREF, make sure you exit out, and then look it up. So RREF, and now it's asking me what matrix do you want to perform this calculation on. So we need to go back in a third time. And then in names, just hit enter on A. And then it's a good idea to close the parenthesis. So it should look like this. Anybody having trouble finding that? Okay. What did you do? So RREF, and then second, math, enter. Okay. Everybody okay? So push enter, and it gives me a new matrix. So write down the new matrix, 1, 0, 3, 0, 1, 4. This new matrix tells me what the answers are. Okay, if you didn't get that same matrix, then go back in and look. You probably missed something. So you typed a 0.17 instead of -17. Okay. Everybody else okay? So in this matrix, the first column represents my x's, the second column represents the y's, and then this is my answer column. So it's taken my equations and it's simplified them. And if we look at the values, the top row says 1x and no y's equals 3, which is just x equals 3. 1x equals 3. The bottom row says 0 x's plus 1 y equals 4, also known as y equals 4. So if you're going to use a matrix to solve this, I want to see both of those. You need to write the resulting matrix, and you need to write the answers. Okay? So let's do number 3 together. Yeah. No, don't put commas. No, oh, you mean here? You can, but nobody ever does. Yeah, don't put them in your calculator, but yeah, I see what you mean. You know, it's never really an issue because you'll get used to the fact that there are 3 numbers. So if there are 2 rows, then there will be 3 columns. If there are 3 rows, there will be 4 columns. So you probably won't need to, and nobody ever does. All right, so for number 3, go into Edit, type in those numbers. Then exit out, look up your RREF. Thank you. Yeah. You always use RREF. Yeah. There is an REF button. Don't ever use REF. It rarely works. Sometimes it works, but not very often. So for my resulting matrix, I get 1, 0, 0, 0, 1, 4. So what are the answers here? X equals 0 and y equals 4. Does that make sense to everybody? So I want you to try let's do number 2. So you use this to find those. So this says x equals 0, y equals 4. Now, did you notice that this pattern was the same in both matrices answers? That will always happen when there's one solution. Okay, so go ahead and try number 2. Plug in the numbers for number 2, and then we'll solve the matrix. I'm going to pause the video for a second. So, do you want to see a trick that'll make your life easier? You can see here on my calculator I have the old calculation. Well, I've gone in and I've changed my A to this new matrix for number 2. Well, I don't need to do RREF again because it was the last calculation I made. So I changed A. If I just push enter, it will redo RREF A, but now A is a different matrix, so it will spit out the right answer. So once you've done RREF once, you don't need to find it again. Does that make sense? You can just change A, exit out, and hit enter, and it will recalculate. So that'll save you some time today. The first time you do it, you always need to find it. The second and third time, you don't need to find it. Well, notice here, this is for number 2. I get 1, 0, 1, 0, 1, 5. What is my x answer? 1. What is my y answer? 5. Notice these have the same pattern. That's what RREF does. It takes the equation and it simplifies it so that it says 1, 0, 0, 1 most of the time. Okay? So if you see this answer, or I mean those matrices, this will be your x answer and this will be your y answer every time. Yes? Yeah. So if you don't see that, that means that your system does not have one solution. So when we graph linear systems, there are 3 possibilities. We have one solution, we have no solutions, and we have infinite solutions. What does it mean to have infinite solutions, or when would you have infinite solutions? When it's the same line twice. So I'm going to put the same equation in twice. So I'm going to go here, 2 by 3. I'm just going to make up an equation. Let's make it easy. 2, 2, 4. That's my equation. If I do the same equation again, 2, 2, 4, this should have infinite solutions because those 2 lines are exactly the same. They touch everywhere. So I'm going to exit out. I don't need to find RREF again. I can just push enter, and I get this equation. So I'm going to write that down, 1, 1, 2, 0, 0, 0. Is that the pattern that I found in the other 3 problems? No. So if you don't see the pattern, that should tell you it's either infinite or no solution. We just need to figure out how to tell. Well, if we look at this, the top row is 1x plus 1y equals 2. Okay, that's just the graph of a line. The bottom row says 0x plus 0y equals 0, which simplifies down to 0 equals 0. When is that true? When does 0 equal 0? Always. So if you have 0, 0, 0 on the bottom, that tells you it's infinity. Okay? Well, let's go in and change my equations. Infinite solutions. Yeah. These 2 lines are the same, so they're an infinite number of solutions. Yeah, that would be good enough. So I'm going to go in here, and if I have 2 lines, 2 equations that have the same answer, those lines are right on top of each other. But if I change one of the answers, that will lift one of the lines up. So I'm going to go over here and change this to an 8. Now what should my solutions be? No solution because those 2 lines are parallel. So I'm going to exit out. I'm going to do RREF again. Do you see the difference? Now I'm looking at 1, 1, 0, and then 0, 0, 1. The top line doesn't really tell me anything of value, but the bottom line tells me 0 plus 0 equals 1, and when does 0 equal 1? Never. So this one would have no solutions. Okay? So if you have that 1, 0, 0, 1 pattern, that tells you there is one solution. If your bottom row is all zeros, what does that mean? Infinite. If your bottom row is 0, 0, 1, what does that mean? No solution. Okay? Look at number 9. Number 9 looks tricky, but it's actually easy. How am I going to enter number 9 as a matrix? So the top row is easy. 3, negative 4, 2. How do I put the bottom row in? It's missing a y. So it's going to be 0y, right. So we'll type in 4, 0, 8. Exit out. I just need to push enter. So I write down the matrix. 1, 0, 2, 0, 1, 1. How many answers does this have? One solution, because I have this pattern. So x is 2, y is 1. And I'm done. Okay? Look at number 17. Number 17 has 3 equations. So when I enter my matrix, what size is it going to be? So we do the number of rows and then the number of columns. So it's 3 by 4. So 3 and 4. And then I just put all the numbers down. 1, 1, 1, 6. 2, 1, negative 4, 15. Oh, negative 15, thank you. Okay. Exit out. And the RREF is still going to work if I push enter, because I've changed the size of A. So now I push enter. Do I have the right pattern? Yeah, it looks a little different because now there are 3 rows, but there's a 1 in the X in the first row, there's a 1 in the Y in the second row, and a 1 in the Z in the third row. So 1, 0, 0, negative 1, 0, 1, 0, 3, 0, 0, 1, 4. So in this case, X is negative 1, Y is 3, and Z is 4. Okay? Now, something funny can happen when there are 3 equations. So if I were to take this bottom row and I were to write 0, all zeros and a 1, what would that mean? No solution. Okay? What if I get rid of the 1 and I put a 0? That would be infinite solutions. But what if the bottom row is all zeros and the middle row is 0, 0, 0, 1? This is kind of strange. So we have 3 equations. So, and this is not really the case, but it's kind of like having 3 lines. So if you have 3 lines and 2 of them are the same and 1 of them is parallel, how many places do the 3 lines intersect? So we have 2 lines that are exactly the same and a third line that's parallel. They never touch. So if you have an infinite solution and a no solution at the same time, your answer is no solution. Okay? All right. Good luck.